The captain pushed the thrust levers forward. The engines responded immediately, accelerating as the Airbus A320 began its transition from landing to climb. But instead of rising away from the runway, the aircraft began descending toward the dark waters of the Persian Gulf. Less than a minute later, Gulf Air Flight 72 disappeared. All 143 people on board were killed. There had been no explosion, no warning of a catastrophic failure, no obvious event that explained why a routine arrival had suddenly become one of Bahrain's deadliest aviation disasters. The aircraft had been operating normally. So how did a scheduled flight from Cairo end in tragedy during what should have been a routine arrival? The answer was not found in those final seconds alone. It began much earlier, during a flight that appeared completely ordinary. On the evening of August 23, 2000, 135 passengers and 8 crew members boarded a Gulf Air Airbus A320 in Cairo for the 3-hour journey to Bahrain. For the passengers, it was a familiar kind of flight. Some were traveling for business, others were returning home. Like countless travelers before them, they expected the aircraft to arrive safely and the journey to become nothing more than another routine memory. Inside the cockpit, the 2 pilots prepared for departure after arriving at the aircraft slightly later than planned. The delay was not unusual, and the crew worked efficiently to complete the preparations and begin the flight. The Airbus departed Cairo normally. The climb was smooth. The aircraft reached cruising altitude, cabin service began, and the hours passed without concern. Nothing during the flight suggested what was waiting ahead. But as Gulf Air Flight 72 began its descent toward Bahrain, the most demanding phase of the journey was about to begin. As Gulf Air Flight 72 began descending toward Bahrain, the quiet rhythm of cruise gradually disappeared. The cockpit became busier. Radio frequencies changed. New clearances arrived. The pilots began preparing for the final stage of the flight, the approach and landing phase, where timing, coordination, and communication become increasingly important. Before beginning an approach, airline crews normally conduct a briefing. It is a chance for both pilots to build the same picture of what is about to happen, the type of approach, expected aircraft configuration, important altitudes, and what actions will be taken if the landing cannot be completed. On this flight, however, the approach briefing was not fully carried out. The checklist item was completed, but the detailed discussion between the pilots never truly took place. At the time, it did not appear significant. The airport was familiar, the weather was favorable, the aircraft was operating normally. There was no immediate indication that this small gap in coordination would become important later. The Airbus was cleared toward runway 12 using a non-precision approach. This type of approach required the crew to carefully monitor their own descent path using altitude, distance, and timing rather than relying on continuous vertical guidance from the runway. For experienced airline pilots, it was a routine procedure. But as the aircraft continued toward Bahrain, the arrival began developing a problem that would become increasingly difficult to ignore. The Airbus was approaching the runway faster than expected. A high-speed approach does not automatically mean a landing cannot be completed. Crews regularly correct deviations during arrivals. But speed affects everything that follows. The aircraft needs more time to slow down. Configuration changes become more demanding. The pilots must manage more tasks in a shorter period. The approach was beginning to demand more attention than the crew had originally expected. Air traffic control continued guiding Gulf Air Flight 72 toward runway 12. But the approach was becoming increasingly difficult to manage. The Airbus remained above the ideal descent profile while still carrying more speed than expected for that stage of the arrival. Either issue alone could have been corrected. experienced crews deal with changing conditions throughout their careers. The challenge was that both problems were developing together. Inside the cockpit, the pilots were now working to bring the aircraft back into a normal landing sequence. Speed needed to be reduced, altitude needed to be controlled, the Airbus needed to be configured for landing. Each task was familiar. The difficulty was handling them all at the same time. Speed brakes were used to help slow the aircraft, while configuration changes began later than usual. The crew was actively correcting the approach, but every correction required more attention as the runway continued getting closer. This is why airline procedures place such importance on a stabilized approach. Before landing, an aircraft must reach a predictable condition where speed, descent rate, configuration, and flight path are all within acceptable limits. If those conditions cannot be achieved, the safest option is to discontinue the landing and try again. That decision exists because continuing an unstable approach forces pilots to solve multiple problems during the busiest moments of flight. And that was exactly what was beginning to happen. The runway was visible ahead. The aircraft was moving toward it. The approach still appeared recoverable. But the crew was now facing a difficult decision: continue trying to fix the landing or recognize that the safer choice was to start over. Meanwhile, the workload inside the cockpit continued increasing. Radio calls, aircraft configuration, speed control, and descent monitoring all demanded attention within a very short period of time. The pilots were no longer simply flying an approach. They were trying to rescue one. By the time Gulf Air Flight 72 reached the final moments of its approach, the landing was no longer developing as a normal arrival. The aircraft was still too fast. The descent path remained unstable. The runway was approaching quickly, and the time available to correct the situation was rapidly disappearing. The captain recognized that continuing the landing was no longer the safest option. The go-around began. The thrust levers were advanced, and the Airbus started transitioning away from the runway. The decision itself was correct, but it came at a critical moment. The aircraft had already reached the busiest phase of flight. The pilots were now attempting to recover from a situation that had developed gradually over several minutes, while simultaneously managing a demanding maneuver with very little time available. As the Airbus moved from landing configuration toward climb, the pilots encountered something unexpected. The aircraft's response did not match what they anticipated. The airplane was following its systems and responding to inputs, but the crew's understanding of what was happening began to fall behind the aircraft's actual behavior. In those seconds, the pilots faced two challenges at once: control the aircraft, understand the aircraft. And the difference between those two tasks became increasingly important. The Airbus was no longer simply completing an approach. It had entered a situation where the crew needed to recognize what the aircraft was doing before they could recover it. What happened next would only become clear after investigators reconstructed the final moments of Flight 72. When investigators reconstructed the final moments of Gulf Air Flight 72, they found that the accident was not caused by a sudden mechanical failure. The engines had continued producing power. The aircraft's structure had remained intact. There was no single component that failed and forced the Airbus into the sea. The answer was found in the interaction between the pilots and the aircraft's automation. During the go-around, the Airbus transitioned through its flight control modes. The aircraft continued operating normally, but its response no longer matched what the crew expected during the maneuver. The airplane was not ignoring commands. It was following them. The problem was that the pilots and the aircraft were no longer working from the same understanding of what was happening. Flying at night over the Persian Gulf, the crew had no outside visual reference to confirm the aircraft's attitude or flight path. Their awareness depended entirely on the information displayed by the aircraft's instruments and systems. As the situation developed, the pilots were forced to interpret changing indications while also trying to control the aircraft. Their attention became divided between understanding the airplane and correcting its flight path. The Airbus briefly climbed after the go-around began. But the recovery did not continue. As the aircraft's attitude changed, control inputs increased while the crew attempted to regain the expected flight path. With only seconds available and very little altitude remaining, there was no opportunity to fully understand the situation and complete a recovery. Moments later, Gulf Air Flight 72 struck the waters of the Persian Gulf. All 143 people on board were killed. The investigation concluded that the accident was not the result of one mistake or one failed system. It developed through a combination of factors: an unstable approach that continued too long, a delayed decision to abandon the landing, increasing cockpit workload, and a breakdown in the shared understanding between the pilots and the aircraft's automation. The accident changed how aviation experts viewed the relationship between humans and advanced flight systems. Modern aircraft are designed to support pilots and reduce workload. But automation can only improve safety when the people flying the aircraft understand what the system is doing, and when the aircraft's behavior matches their expectations. Gulf Air Flight 72 remains a reminder that even highly reliable aircraft depend on something beyond technology alone. They depend on a clear connection between the humans inside the cockpit and the machines they command.